Okay, so in this video, what we're going to do is solve this problem where there's water in a tank and there's a hole at the bottom of the tank, and it is observed that the water at any instant, at some particular time, the water draining out of this hole falls this half a meter, okay, in 0.1 seconds. Okay, and our goal is to basically figure out the height of the water in the tank. So our eventual goal is to figure out this height. Okay, and we're going to do it by figuring out the speed first at the bottom, at the hole, and then everything else. So now to find the speed at the bottom, okay, so first thing is determine speed. Now to determine the speed with which water leaks out of the hole, we're going to use one-dimensional motion. Okay, so let us make our chart. So we have delta x, vi x, vfx, ax, delta t. Now we could have written ay and all that. It really doesn't make any difference in this case. It's one-dimensional motion. It's all good. So we have negative 0.5. We'll leave the vix as we'll just call it v2 because that's going to be the 2 for the next part of the problem. VFX we really don't care about, and negative 9.8, and the time is given as 0.1 seconds. Okay, so we're going to use one of our equation, which is delta x equals vix delta t plus 1/2 a delta t square. Okay, and in order to do that, what we'll do is we have all our stuff. We have negative 0.5 for this. Vix is what we're finding, which we'll call v2. The time is 0.1. and it's half times negative 9.8 multiplied by 0.1 square. Great. So you get negative 0.5 equals v2 times 0.1. Okay, and this ends up giving us negative 4.9 times 0.01, so it's negative 0.049. Okay, so now what I can do is I can move my 0.049 to the other side, and I get negative 0.5 plus 0.049 is equal to v2 times 0.1, and what this gives me is negative 0.451 equals v2 times 0.1, and v2 ends up being equal to negative 4.51 meters per second. Now the negative sign here simply implies that the object is going straight down. Okay, that the water is going down. So in our equations we don't really need to worry about it, but this is what we get. Alright, so now we can use Bernoulli's equation, which says that P1 plus 1/2 rho V1 square plus rho GH1 equals P2 plus 1/2 rho V2 square plus rho GH2. Great. Let's set all this up. The pressure at the top we know is the atmospheric pressure. We'll just call it P0. Okay. Then we know the speed at the top is close to 0 because the tank is much larger compared with the hole. The size of the area at the top plus the height is what you're looking for. So it'll be 1,000 times 9.8 times some h1. Okay, and at the hole the pressure once again is the atmospheric pressure because that's what it's exposed to, plus 1/2 times 1,000 times 4.51 square, plus we'll take the height of the hole to be 0, so this becomes 0. Okay, so then we can measure h1 h rather from the height of the hole. Okay, so the pressure cancels out, and what we are left with is this: 1,000 times 9.8 times h1, which we call h, is equal to half of 1,000 times 4.51 square. Now if you look at this, the 1,000 cancels out, h is now equal to 4.51 square divided by 2 times 9.8. And when you evaluate this, you end up getting 1.03 meters. Okay, so this is the end of this problem.